All right, time to finish up AP Chemistry with the last unit of the year, and that's organic chemistry. This is probably my favorite part of chemistry, but unfortunately it's just a small piece of the AP Chemistry spectrum. So organic compounds, it's actually a name that doesn't really make sense anymore, but it's stuck around and so we still use it. Organic compounds, originally they thought they only came from living organisms. So they originally thought that these organic compounds that they found, the guy who coined the name was Jöns Jacob Berzelius, and so he thought that organic compounds came from living things, and then that there was inorganic compounds, and those came from non-living things. Kind of the original train of thought back then was that you couldn't use organic compounds to make an organic compound, so there was no way from dead things to make an organic compound, essentially. And by dead things, I mean things that have never been alive, so dead leaves would have still been organic compounds. Then, however, in 1828, urea, which is an organic compound, it was made by taking two inorganic compounds, so ammonia and cyanic acid. Those two were combined, and that made this organic compound right here. It's a component of animal urine, urea. And so what they found then was, okay, organic compounds don't only come from living things. They can be synthesized in the laboratory from inorganic things. And so really the name doesn't make sense. It doesn't come from living things anymore, but it still is what we use. Today, the best way to describe an organic compound is compounds that contain the element carbon. So one thing that all organic compounds will have in common is carbon. They will all have carbon in them except for things like carbonates, carbon dioxide, carbon monoxide, diamonds, and graphite. All of those are made of carbon, but they're not organic compounds. So all organic compounds contain carbon, but not all carbon compounds are organic. Okay, here's a list of some things that are organic compounds. So rubber is organic, latex, silk, nylon, methane gas, and motor oil, gasoline that we put in our cars, plastic, drugs, all of those are organic compounds. What makes them organic is all of them are carbon-based. So all of them have some kind of chain of carbon that makes them up, and the number of carbons is what kind of deciphers its properties, what type of organic compound it is, that kind of thing. And as you're looking at this list, you're probably thinking, what? How did they ever think that this came from only living stuff? But, you know, it was back in the day. We're talking about the 1800s. And a lot of these things, like silk that comes from silkworms, and so that would be considered organic. Methane gas, that comes from decaying material, so that would be organic. Drugs, when we talk about drugs, so things that we take into our bodies, whether it be aspirin or methamphetamines, those are all things that interact with the life forces inside of our body, with kind of our biological processes, so that would be organic as well. Things like rubber and nylon and plastics, those are things that we've discovered more recently. Organic compounds make up 90% of the compounds that we know, so approximately 20 million compounds, known compounds, 90% of them are organic. So why is that? The carbon chains, they can form these huge long chains of carbon, and there's all kinds of different ways you can organize that. So I mean right there's 4 carbons. We could also draw 4 carbons like this. You know, we can organize them in different ways, and we can have double bonds or triple bonds in some places, and that's going to change the behavior. So there's just a variety of combinations you can have, and we're still discovering new organic compounds. It's not like we're done with them. On the other hand, something like water, think of like H2O. How many different combinations are there for water? There's just the one. Or, you know, like sodium and chlorine. How many different ways can you combine sodium and chlorine? Just the one way. NaCl, that's it. We're done with it there. Organic compounds, though, they're constantly finding new ways to arrange these carbons and hydrogens and other molecules like oxygen, nitrogen, and sulfur, and the halogens to create these new organic molecules. And as we're coming up with new medicines, tons of those medicines, most of those medicines are organic molecules. And so when they come out with a new medication, they're coming out with a new organic molecule. It's usually something they found somewhere, figured out what it is, and then engineered a process to make it. So for this reason, organic chemistry is kind of its own branch, separate from all the other chemistries. You know, it still entails chemistry. It's a lot of the same concepts, but you can devote your life to studying just the organic thing. No pun intended.